All right, so let's look at page 83. We'll try to keep this just as brief as possible. All right, 83. We've talked about a mole. The simplest way to look at what a mole is would be what in chemistry terms?
A dozen. 12.
Yeah, I suppose when you're referring to a dozen, more so just a counting unit. It refers to how much of a substance that you actually have. Okay, and with that, what constant did we use yesterday? Avogadro's number. Now, probably the biggest bit of information I can pass off to that, don't use your caret symbol. Okay, and I understand that's probably on there, and you believe that you're actually utilizing the correct. What I want to say, function, when you use that deal, it looks like a roof tiling of a house. Don't use that caret symbol. That is a totally different function than what scientific notation is. You use that caret, you're actually squaring it, you're actually cubing it, taking it times the 4th power, whereas scientific notation, it just tells you how many times you're moving that decimal place, left or right. All right, so molar mass. This concept of molar mass you'll be using from here probably all the way through March, maybe April, until you get to the organic portion of junior high, the organic portion of junior year. All right, so a molar mass. An alternative definition of mole is the amount of a substance that contains Avogadro's number of particles. You can figure out the approximate mass of 1 mole of helium atoms. You know that a mole of carbon-12 atoms has the mass of 12 grams, or exactly 12 grams, and that a carbon-12 atom has an atomic mass of 12 atomic mass units. So for any element on the periodic table, okay, I always just use sulfur as an example as well. If I put, well, for instance, with carbon, if you put approximately 12 grams of carbon in here, it just says you have how many moles of that would you have? Exactly 1. If you put 32.06 grams of sulfur in here, how many moles do you have? 1. For every time you get the atomic mass of that substance, that is a counting unit of 1 mole of that substance. Now, that doesn't mean a whole lot to you right now, but as we put that together in some of these concepts, as we proceed forward in this curriculum, it'll become more evident. Now, you might be saying, I don't want to learn this stuff. I'm going to be a even physical therapist. I'm going to be a nurse. I'm going to be a athletic trainer. These types of classes, you still have to have them to get through your college major when you go to USD, SDSU, or wherever it is. So therefore, if we got that good foundation, hopefully we can make you successful upon that next step in your venture. All right. So of course you could say helium. If you have 4 grams of helium, you would have a mole of that. Okay? And if it says if you have 4 grams of a substance, which is about 1/3 the mass of carbon-12, why would we say helium is 1/3 atomic mass units compared to carbon? What's 4 out of 12? 3. So that's why it's 1/3. Okay? Makes sense? I don't want to be going so fast that, oh my gosh, I'm lost right now. All right. Now, the next paragraph, the mass of 1 mole of a pure substance is called the molar mass of that substance. And that's all the further we want to go, other than the label of grams per mole. Go ahead and flip the page. Okay. One of the things that we always deal with here is saying we've got sample problems. You can always go back through and look at the sample problems, because what it's doing is showing you how to do each one of those. What we do is we just skip right ahead to the practice problems. Okay? So what we see here on page 85 then, practice problem number 1. What is the mass in grams of 2 1/4 moles of the element iron? Okay. So in order to do that, okay, that's how humid it is. It sticks right to the whiteboard. Okay. Good old physical science days, right? The alligator? Yeah. Yep, that's right. So very similarly to that of physical science, there's only one number to start with. What were you given in this problem? 2.25 what though? Okay, 2.25 moles. And what substance are we dealing with? Now, this is another aspect that I can't stress enough. Put these labels on here. We're not all, I'm going to pick on this student, we're not all Keiths. We're not all Keith or not all Keiths from a year ago. He was, I would say, very notorious for not putting these labels on here. Was he smart? Yes. But the problem is if he has questions that he's asking, it's very hard for me to help you when you don't put these labels, because it just confuses me. Okay? I'm not a chemistry professor, and I think it's just good habit to move forward with these labels. Now, here we got a couple of people going to answer this. Would you suggest that they showed their work and their labels? What happens if you don't? You'll probably get the problem wrong. Sometimes you're lucky, but more often than not, you're probably not going to learn this correctly, and there's nothing more costly than having to take a college class twice, because I've had to do that before. It was the organic, we didn't have that in high school. I had to take organic chemistry twice, because that's one of them things for some of you who have expressed interest in the medical fields. Hopefully we give you not just enough, but hopefully the correct amount of background so that when you do get into college, you're already comfortable for that first 6 weeks just reviewing of what you learned in high school. And why is that important? Because it just gives you that extra bit of time to spend on maybe other classes that may need that, like anatomy and physiology. This is just a 2-step problem. Because what is it asking for? What's the grams, right? What's the mass in grams of 2 1/4 moles of the element iron? So just like that dimensional analysis yesterday, if you see something on top, how do you cancel that out in the next step? Put it on the bottom. So for every mole of iron, it's asking how many grams of iron is there? Well, we're not just going to pull a number out of the air. That's where Bob is useful for you over there on the west wall, or this guy right here. Okay? So call your periodic table whatever you want. Call it your sweetheart that you have, or your favorite guy that you have, or it's got to be someone in this school, right, ladies? Right, guys? It's got to be some lady in this school. Okay. Oh, okay. I got you. Okay. So what is the molar mass of iron? Well, you just don't pluck it out of the air. That's what the periodic table is for. Look at element 20. Is it 25 or 26? 26. What does it say inside that box? 55.85. And you just get that from the periodic table. Okay? This is why we call this a molar mass, because you have moles and you got a mass in grams. So sometimes moles is on top and grams is on the bottom. Sometimes grams is on top, moles is on the bottom. It just depends which you start with. Okay? It's asking for a mass in grams, right? So what did these two labels do? What are we left with here? We're left with grams of iron. So since these are next to each other, what do you do with those two numbers? You multiply them, okay? And with that, you might get a decimal. This says 126. You must get 125 something. You round it up to 126. Is that pretty safe to presume that? So you get 125 point what? And then what's after this next 6? Okay. Then we'll do grams of iron.
6625.
Oh, okay. Ah! There. Okay. So that's how you solve that one. Okay. Notice that the rest of these are all labeled in moles. Okay. We'll come back and do some of those later on. I just want to look at the bottom of page 85 so you can actually put this molar mass to work. So number 1, number 2, or number 3 on the bottom of page 85? Number 3? Number 3. We'll do them all, but it's just that which ones are we doing today? So this one's number 3 on the bottom set of practice problems. It says, how many moles of zinc are in 0.535 grams of zinc? Okay, there's only one place that you can start. Okay, and that is 0.535 grams of zinc. Okay. So in our next step, okay, we need to get rid of that gram. I don't know. Yeah, you can see that on there. So how do we get rid of grams in our next step? Put it on the bottom. Grams of zinc. And then from the periodic table, notice this was moles per gram. Okay? Or grams per mole. This time it is moles per gram. We left a little space there because what are we going to put in that space? 65.38, so 65.38. What happens to these grams? And the author is saying you should get 8.18 times 10 to the negative third.
So you now divide those two.
You now divide them too. Because 0.535 times 1 divided by 65. But what it might do is spit out this answer. 0.00818. Which is the same as this 8.18 times 10 to the negative third. These are the same number. Okay? The bottom one is just scientific notation. Okay? With practice, when you see a negative exponent as opposed to a positive one, it tells you which way the decimal is moving. Okay? Now, we went over those two problems really, really fast because it's hot in here, it's miserable in here, it's not fun being in here, but we just had a simple task that we wanted to accomplish, what we have, and I befuddled the freshmen when I said, are we on the bus over here? Middle, are we on the bus? And right side, are we on the bus? All right. So very good. So next week, the very first paper that you have is just adding together those atomic masses. That's worksheet 1. And then as you can see on Tuesday, it's talking about grams to atoms and atoms to grams. Those are 3-step problems. These are just 2 steps. Next time on Tuesday, after getting all these done, then we start using Avogadro's number again. Okay? And then we'll see once how the rest of the week unfolds, but that's a short version of what we're doing next week. All right, that's all I got. We'll catch up to you next time.